Well, this tutorial is going to look at using the SOP solver to achieve effects in Houdini. And the effect that I'm going to demonstrate is one that was originally demonstrated as part of a digital tutors training series on Softimage's ICE. And I began to think about how we could replicate the effect in Houdini, and it turned out to be a reasonably good way to demonstrate the SOP solver. So here's the effect that we want to achieve. So there are a number of ways that we could achieve that effect. One would be to create groups of points, perhaps based on animated bounding boxes, and we would essentially animate the effect by hand. That in fact might be the easiest way to do it. But the purpose of the tutorial is to demonstrate the SOP solver, so we'll have a look at a different method. And the method that we're going to use involves creating attributes on each of the points of our box here, or our match, and spreading them across the length of the match as time goes on. And there will be two issues that we'll face as we do this, one of which is that there isn't a node in Houdini that will spread the values quite as we might want. The attribute transfer SOP rather, can do some of what we want, but it's not exactly what we want. So that's the first problem, and we can solve that by creating a VOP SOP, some bespoke VEX code, which will help resolve that. The second problem is more fundamental, and that's to do with the fact that what we're essentially doing is trying to calculate new values for the attributes based on the values at the previous frame. So for example, in the first frame we may have a high heat value here at one end of the match and the rest of the match with a value of 0. And in the next frame we want to calculate heat values for the match by comparing nearby points and heating up the points which have points near them which are already hot. And we can see that we can't actually do that in a normal SOP network. A normal SOP network relates quantities to each other and to the frame number. It's essentially about static animation that isn't dependent on the previous values, the values in the previous frame. And I'll just demonstrate this with a quick example. I'm going to create an attribute. We're going to call it heat. And I'm going to give it an initial value of 1. And if we bring up a details view, we can see that it's created a value of 1. And then I'm going to add another attribute create. And by the way, attribute create can be used to change values of attributes as well as create them. And we're going to take the value of heat and we're going to add 1 to it. And the effect we want to achieve is that at each frame the value of heat increases by 1. So we start with a value of 1, at the next frame it goes to 2, it goes to 3, and so on. And in fact what happens, as we can see, is that the value of heat stays at the value of 2. And that's because in this network it's being evaluated at every frame. At every frame it creates a box, it creates a heat attribute with a value 1, and then it adds 1 to it, so we get the value 2. We could animate heat by frame number, but that's not exactly what we want to achieve here. So we need a method to allow the attributes on our geometry to vary based on the value of the attribute at the previous frame. And that's not possible in a SOPs context. But that's the entire purpose of the dynamics context. The dynamics context is all about basing new values on the values at the previous frame. So we need to somehow operate on our attributes here in a DOPS network. And that's where the SOP solver comes in. So let's start by getting rid of these attributes. I'm going to create a new attribute, but first I'm going to select the points by hitting S and then 2 and selecting the points here at the end of our match. And let's lay down an attribute create. So now I'm creating just on the end of the match, and we'll call the attribute heat again, and we'll set it to an initial value of 1. And what this should have produced is that the points at the end here, which have been selected, will have a value of 1, and the rest of the points will have the default value, which is 0. And indeed, that's what we've got. Now we need to bring this geometry into DOPS, and you can do that by hand, but probably the easiest way to do it is to use a shelf tool. And I'm going to use the RBD object tool. That's the one that works for this. A static object won't work, but an RBD object will. So let's select our object and then hit the RBD object shelf tool. And this creates an auto dot network. I'm going to dive inside, and I'm going to get rid of everything apart from the box object. We're just using the self tool to create this object. And what we need is a SOP solver. So let's lay one of those down. So what is a SOP solver? Well, let's have a look using the details view at what data we have here in our DOPS network. Well, we've got a box, and on the box we have a set of data called geometry. And if we have a look at it, the geometry is essentially exactly the point and attribute information we had in our object. But it isn't a reference back to that object, it's a copy of that data, at least if you use an RBD object RBD object DOP here to create your object. So this is a copy of data, and it's now DOPS data. And because it's DOPS data, you can change it and the value will be remembered by Houdini for the next frame, and you can then base new values on the past values of these attributes. So the SOP solver has a network inside it which looks exactly like a normal SOPs network, except that instead of operating on some geometry from the geometry level, it's actually going to operate on this data. From the point of view of the nodes in here, it won't look any different from operating on a normal object, but in fact the results of that network are going to be stored in this geometry data. And if we have a look at our SOP solver, we can see that the data name that it operates on is geometry by default, which is this. The group tells it to operate on all the objects that are coming into its input, and since there's only one, that's fine. And the SOP path here is a dot by default. Now you can set up your SOP solver network in a separate SOP network and then point to it using this selector, but the easiest thing to do is to store the SOPs that make up your SOP solver inside this node itself, and that's how it's set up by default. That's what this dot means. So if we double click to go inside, we can see that we get 2 nodes for free. We get a node here called impacts. We're not going to be using this. It essentially is a way to bring impact data into a SOP solver, and it has a DOP geometry node here, and that's an object merge with a very complicated expression here, the result of it is to bring the geometry that we want to process into our network here, where we can process it using normal SOP nodes. And then the result of that is taken back up here to the top network and placed into the geometry data that's attached to our object.